I am going to talk you through and show you how to solve for standing waves. And this is a handout that's on the website, and these are just a set of practice problems here. I want to look at the layout here. We're going to be talking about different harmonics, and we'll start off with fundamental. We'll be looking at the second harmonic, the third harmonic, fourth, fifth, and sixth. And the picture, if I were to draw this out, we know that we have these wave boundaries, and that's important. It's important that you realize that these wave boundaries need to stay the same. We'll be doing these together kind of as we go, but I'm just going to get you started. Notice I have this amount of information given. I know that the fourth harmonic has a 100 hertz frequency, it has two total wavelengths, and it has a wavelength of 0.5 meters. So I can apply the basic knowledge that I have as velocity is frequency times wavelength. I know the frequency is 100 hertz, and I know my wavelength is 0.5 meters. If I take 100 times 0.5, I get a wave speed of 50 meters per second. Well, that's important here because I know that my wave speed for all of these is traveling through the same media, so therefore my wave speed is going to be constant at 50 meters per second. So I can go ahead and fill this in, 50 meters per second. Now, from here, what does a picture look like? Well, I know my wave boundaries are located at the same distance apart. So I'm going to just draw this in, and it's going to look like this. And I know here that this number, the number of wavelengths, this has one wavelength, two wavelengths. So that's where these numbers come from here. So I'm going to jump into the first harmonic. And in this case here, I know that it's got four, in this case here, it's going to have a frequency and a different size wavelength. And if you notice that in this case here, this is only 1/2 of a total wavelength. So based on that, if I know my wave speed is 50 meters per second, it means I have to use information down here. So before I jump into my fundamental, I kind of get ahead of myself, I might as well jump into my second harmonic. So I'm going to work backwards. So this is going to be me showing you how to solve for several of these. Possibly not all of them. I'll kind of give you enough information. There's an answer key provided. So I'm going to jump into this one. I notice that my second harmonic is going to have 1/2 the frequency. So it's going to be 50 hertz. And as a result of this, the wavelength is going to be twice the wavelength, which is going to be 1 meter. I know this because I'm really looking at, if I know my wave speed is constant, right? This is constant. If I have half the frequency, I must have twice the wavelength. So I just apply this, the equation, I'm looking at it conceptually, half the frequency of the second harmonic is going to have twice the wavelength. And if I look at this picture, this is one full wavelength. So now I'm going to use this values right here to solve for my fundamental. Notice this is going to have half of this frequency, which is going to be 25 hertz, and it's going to have twice this wavelength, right? 2 meters. In other words, this total distance here is, this picture that's represented by my fundamental is only 1/2 of a wavelength. If I look at this and I graph this like this boundary right here is only 1 meter, 1 meter from here to here. So I know that because my second harmonic fits the boundary, and I know that it's got a wavelength of 1 meter. So let's look at my third harmonic, and I can draw it like so. And I'm going to draw this, I'm going to draw this, I'm going to draw this, and get my, notice my one wavelength here is going to be 2/3 of 1 meter. So it's going to be 0.6 meters, 6 repeating. So a lot of times I write that as 0.7 meters. And in this case here, it's going to have a frequency of 75 hertz. It's going to be 3 times the frequency of my fundamental. So 3 times 25 is 75 hertz. Notice my fifth harmonic. So now I'm going to have to start getting a little bit trickier here. And I'm going to need to finish this up because I have a class coming in. So 1, 2, 3, 4, 5. My fifth harmonic, notice how small this wavelength is. And that should make sense to you because I have 5 times the frequency of my fundamental, so 125 hertz, but yet it's going to be 1/5 of my total wavelength, and this is going to be 0.4 meters. Now, I'm simply using the equation, speed equals frequency times wavelength. I keep on reminding you that the wave speed is constant. Notice I have one wavelength, I have two wavelengths, so here's one wave, wavelength, here's two wavelengths, and I have a half. So this is going to be 2.5 wavelengths. And for my sixth harmonic, now these are going to get small. So 1, 2, 3, 4, 5. So here's this. I'm drawing this out. And 1, 2, 3, 4, 5, 6. Now it's going to be 6 times this frequency, right? It's the 6th harmonic, so it's going to be 150 hertz. And I'm going to have 1/6 of 2 meters, which is 0.3 repeating meters wavelength. And notice I'm going to have 3 total wavelengths in here. Here's a wavelength, here's a wavelength, here's a wavelength. And here, even though I went fairly quickly, you can always stop and rewind. I really talk you through how to solve the problems within here at looking at different harmonics. First harmonic, if I outline this a little better. Second harmonic. Third harmonic. And these are drawn vertically, so we can look at it a couple different ways. And that's how you go about solving for standing waves. First harmonic, second harmonic, third, fourth, and fifth. And you'll want to make sure you get practice with this. There you go.